Rahim. Our next topic that let T1 and T2 be the linear transformation from the vector space U to the vector space W over the same field F. T3, T4 be the linear transformation from the vector space W to the vector space V over the same field F. Then prove that the composition of T3 on T1 plus T2 is equal to the composition of T3 on T1 plus the composition of T3 on T2. Since T1 and T2 be the linear transformation from the vector space U to the vector space W over the same field F, then by a previous theorem, the sum of the linear transformation T1 and T2, that is T1 plus T2, is also a linear transformation from the same vector space U to the same vector space W over the same field F. And the T1 is a linear transformation from the vector space U to the vector space W. Therefore, T1x is an element of W. Similarly, T2x is also an element of the vector space W, because T2 is also a linear transformation from the vector space U to the vector space W. And T3 is a linear transformation from the vector space W to the vector space V. Therefore, the image of T1x under the linear transformation T3 is an element of V. That is, the composition of T3 T1 is a linear transformation from the vector space U to the vector space V over the same field F. And T2x T2 is a linear transformation from the vector space U to the vector space W. Therefore, T2x is an element of W, and the image of T2x under the linear transformation T3 is an element of the vector space V. Therefore, that is the composition of T3 on T2. The T3 and T2 is a linear transformation from the vector space U to the vector space V. Also, the T1 plus T2 is a linear transformation from the vector space U to the vector space W. Therefore, the T1x is an element of W, and T2x is also an element of the vector space W, and W is a vector space over the field F. Therefore, the sum of T1x plus T2x is also an element of the vector space W, which is also equal to T1 plus T2x, where x is an element of the vector space U. That is, T1 plus T2x x is an element of W. That is, T1 plus T2 is a linear transformation from the vector space U to the vector space W. Hence, the composition of T3 on T1 plus T2 is an element of V. That is, the composition of T3 on T1 plus T2 is a linear transformation from the vector space U to the vector space V. That is, T1 plus T2, this resultant element is an element of W. T3 is a linear transformation from the vector space W to V. Therefore, the image of the image of T1 plus T2x under the linear transformation T3 is an element of the vector space V. That is, the composition of T3 and T1 plus T2 is a linear transformation from the vector space U to the vector space V. That is, T3 composition of T1 plus T2, T3 composition of T3 composition to T2 is a linear transformation from the vector space U to the vector space V over the field F. Let T1 plus T2x is equal to T3 composition to T1x gamma T2x, according to the, which is also, this is also equal to the composition of T3 and T1x gamma T2x, which is also, where T1x, T2x are the element of the vector space W, which is also equal to T3 composition to T1x gamma T3 composition to T2x, which is also equal to the composition of T3 T1x plus the composition of T3 T2x, which is also equal to composition of T3 T1 plus composition of T3 T2x. That is, the composition of T3 on T1 plus T2 is equal to the composition of T3 T1 plus the composition of T3 T2, which is our required result.